Hello friends, welcome to the part 3 of the tutorial series on object detection using TFlite Model Maker. In the previous video, we have created our dataset and annotated all the images in our training and validation folder. Now, in this video, we will move forward one step and develop a model using TFlite Model Maker. To learn more about object detection with TFlite Model Maker, you can head over to Tensorflow official web page and learn more about it there. Here, I have created a train model.py file which utilizes the TFlite Model Maker and train a model. Further, it saves the model as well. Before you run train_model.py file, there are some configuration that you need to do. First, epochs, how many epochs you want while training. Then batch size, this both will depend on the problem and the hardware you have. The third is classes. Since these classes we have developed, or you can say we have created these classes when we downloaded the images and created dataset out of that. Further, there is a model name that whatever you want to name your model with, you can choose that. I have used celebrity detector.tflite. TFlite is extension and it is must. The next thing is model. So there are, at this point of time recording this video, TFlite Model Maker only supports efficient DNet, and there are 5 versions of that: efficient DNet Lite 0, 1, 2, 3 and 4. Here, for this demonstration purpose, I am going to use Lite 0, which is smallest in the size. So once the configuration is done, what you can do is head over to this training model py file, and you can see I have used those configuration variables here, and there are only few things. First, there is data set development, train data and validation data. Then there is a model, and there is a model.create which will start training our model. Then model.evaluate, it will evaluate our model on the validation data. And then model.export, this will export the model to the model directory. So let me try running this. While it start training, there is one alternative way to train your model. You can use Google Colab GPU in order to train your model, and then you can download the model from Google Colab. So in order to achieve that, what you need to do is first you need to upload the images on Google Drive, and then go to Google Colab, create a new Colab notebook, mount your Google Drive and then run the same code there. Since it has started the process, I will get back to you once the process finishes. See you on the other side of the video. So you can see that the process is going smoothly. First epoch and then second epoch, and then this third, fourth is almost finished, and it has started the fifth epoch as well. I really like the way it shows the progress. Now the process of training and saving the trained model is finished, and you can see that there is a saved model under models directory. Now let's test the trained model. Before we test the trained model, there is one small configuration that you need to do, is that detection threshold. I have set to 0.3, but you can change it to your case. So let's go to this test, and when you want to run this file, what you need to do is there is a variable input image path. You need to set the variable with your image. So I'll go to dataset and test and get the image of Bill Gates, and let's copy the relative path. Let me provide it here. So when I'll run this file, it will create two files under results folder, input and output, so that we can verify it. Let me run this. I'm myself not sure about the result as well, since we have run it for like 5 epochs. So this is the output image. Oh, it is not able to detect the face inside the image, but I'm not afraid of that, because this is because we have run it for like 5 epochs. But let's say if we run it for like 10 or 15 epochs, then the result may be different. So let me come back again, and let me just run it for like 20 epochs and come back again to see what the difference. So let me set the configuration to 5 epoch to, let's say, 20 epoch. Let me save this and let me run this python train underscore model.py. Now I have run for like 20 epochs, and let's test the results. Let me run python test.py. As I said earlier, it will create two files, input and output. So this is our input image and this is output image. Now it looks good. So we got the output Bill Gates. Let's try one more. Let's say Elon Musk. Okay, so let me copy the path, relative path, provide the path here. Let me save this. Let me run the code. Let's see the result. Okay, now we got something working. So that means if you have a big data set, hardware to train the model, and if you can run for like let's say 500 epochs, the model will perform very well. So this is it for this part of the video. See you in the last section of this video series on object detection, and in that we will serve this developed model with Python and Flask API. If you like my work, please consider subscribing to my channel. Thank you for watching. Peace.